Hi, folks. Welcome. Thank you for joining. This is the Oracle Autonomous Database Learning Lounge. I'm Marco Seracibia, part of the product management team for Autonomous Database. And today we have a very special session on Don't Stop Me Now, the high availability and disaster recovery story of our Oracle Autonomous Database. So today we're going to have Nilay Panchal. He's a principal product manager in our team. He's going to be explaining to you guys, how does the, under the hood of the high availability and disaster recovery infrastructure works, right? What are the things that make the autonomous database so good as it does? So you're going to also learn how, administrators can shield their users from planned outages, right? From avoid unplanned and predictable outages and with using autonomous data guard and backup disaster recovery as well, right? So throughout the session, we're going to have product managers available to answer all your questions. If you need to ask us a question, please make sure to use the Q&A section in Zoom, okay? And we're also going to distribute to you guys some links using chat. So before we begin, basically, these are some important links for you guys to keep in mind. I'm sharing them right now in the chat, so that you guys can use them. These are just information about, the Get Started site for Oracle Autonomous Database, how to join us in LinkedIn and also in Twitter. And also, there's also a new place for you guys to ask your questions, right? Not only a Stack Overflow, but also in Slack. So we have a external Slack workspace that you guys can join. So if you can click on that link, you're going to join that Slack channel, and you can search for a particular Slack channel, Oracle Autonomous Database. And we're there basically, talking about events, sharing information about new things, but also answering your questions. Okay. Thank you again very much for joining, guys. And Nilay, thank you for joining. I will stop sharing and let you share your screen. And again, take it away.
Cool. So thanks, Marcos. Yeah, so that was interesting. So, a majority of you are aware of disaster recovery in HA in ADB, but, you may not have used it in a project, may not be familiar with all of the options that are available to you. So I'm hoping that this overview sort of gives you the, the full context of everything we have for HA and DR in ADB. And then, of course, we will have future more detailed presentations going deeper into application continuity and full stack disaster recovery and those kinds of things in the future. So let's just dive right in. I just want to give a brief couple of slides of an overview here of what autonomous database is and the ethos behind it. So overall, everyone here should be familiar, hopefully, with autonomous database. But the idea with autonomous database is that it's a fully automated, fully self-patching, self-fixing, essentially, database, right? It's auto-patched, auto-backed up, elastic with auto-scale, disaster recovery, which we'll talk about at the end of the presentation, is going to be, basically a few clicks. So the overall idea here is that autonomous database, reduces the amount of effort and the amount of cost that's actually built in terms of human effort, but also primarily reduces risk, right? The risk associated with actually not setting up some of these automated features is completely taken away with autonomous database and is, always up to date. So we'll go through some of the features that, really help these features of reducing cost and risk and simplifying, accelerating time to value really stand out with disaster recovery and all these other automated features, right? So again, just as a broad context, we have three sort of broad deployment types for autonomous database. One's in a public cloud. One is, clouded customer, which is autonomous database dedicated. And then we actually have dedicated regions for, basically customers that have a huge deployment and require a full region. But the idea here is we broadly have two categories of autonomous database, which is serverless and dedicated infrastructure, which you've probably heard of. Serverless, is sort of the smallest possible deployment type that you can have, but can be auto-scaled or scaled, into as as much of a deployment as you need. Whereas dedicated infrastructure is, dedicating a certain amount of pods or Exadata machines for your particular requirement or for your particular needs, and that's obviously associated with larger deployments at a starting point, right? So with serverless, you can start off now with even smaller databases than before, which is as small as 2 eCPU databases, right? And within this category of serverless and dedicated, we actually have a couple of workload types based on the kind of data and the kind of querying that you may be running your workloads on. So data warehousing and transaction processing, you're probably familiar with, which is, data warehousing is to build data warehouses, basically run analytical workloads for larger amounts of data and aggregated data, and transaction processing built for, transactional workloads, high concurrency, fast running applications, those kinds of things, as well as mixed workloads. So that's, we have those couple of options. And then we also have smaller, cheaper versions of these databases, which are more specific to the kind of workloads that you're going to be requiring. Apex, if you're going to be building low-code applications in Apex, then you can actually provision an individual Apex service as opposed to provisioning a DW transaction processing. As well as if you're going to primarily be working with JSON data or no-code kind of, NoSQL kind of implementations, then you can also build a JSON-centric application by provisioning a JSON service, right? And so those are the sort of four broad workload types. But as you can see, there's a whole ecosystem of tools that become available to you when you provision autonomous database, right? You have Apex, you have SQL worksheets, you have notebooks with Oracle machine learning. You actually have data lake availability as well, spatial graph. All of these things come with autonomous database or can be provisioned within an autonomous database, right? So let's actually jump right into the high availability features that is the crux of this topic, right? So we're calling this as a broad category of not just high availability, but continuous availability. So as you're probably aware, ADB is built over Exadata as of today, and this is highly available fault tolerant architecture. Every database is basically built over rack, is built over real application clusters for any kind of node failures, and is by default is built in with redundancy and triple mirrored storage. If you're familiar with Exadata, which I expect many of you on this call are, this is the best in class infrastructure that Oracle has to offer. And in addition to the best in class infrastructure, we've built the ability to basically online patch and upgrade your autonomous databases in a way that the intention is for it to really never go down, right? So patching is online. We actually have maintenance windows that we publish for you to be able to be aware of any connection drops or anything like that during a very specific period. And you always basically have an up-to-date database with the latest security patches, which are, like I said, patched online without any downtime. So I just wanted to, highlight how important patching here is, because one of the, more, not, I wouldn't say complicated, but the more time-consuming / effort consuming, part of any database is making sure it's upgraded and patched, right? So we actually automate patching entirely in Autonomous Database, and patches are applied with zero downtime, right? There's a scheduled maintenance window, as you can see here. And during that maintenance window, your database is patched without ever, without ever having any minutes of downtime. We might have dropped connections during this period of time, which is where application continuity comes in. And we'll talk about that in a couple of slides. So basically, you're able to mask away any connection drops from your application entirely. But there will be no downtime during these events. And of course, built into this will be, we have event notifications and the patch history, as you can see here. So it's all available to you to understand exactly when your patching is about to happen. In addition to just basic patching, we also have the ability for early patches. And these early patches, if you have an early patch database, this actually gets patched 1 week prior to your regular patching cycle of your primary database. And this early patch database allows you to actually go in and test and make sure your application works without any hiccups. And if there are any hiccups, you can reach out to Oracle, or make sure that your mission critical databases are working well basically with the upcoming patches. This is a really important thing for testing and making sure that basically your application is going to have no downtime. So in addition to patching, that is sort of is a really important aspect of autonomous database, but it's just taken care of for you. There's a whole bunch of metrics and alarms that we have set up that basically detects, as mentioned here, a large percentage, up to 87% of issues, basically without any interaction from the customer at all. So I just want to highlight that we have, this is the number of metrics and now we have set up, but there's a lot going on under the covers to make sure your database is available and is working as expected, without you having to set up events, without you having to set up notifications with SRs that we have that automatically get filed. In addition to these metrics that we have set up and alarms that we have set up, you of course have metrics that are user facing and alarms that you can create on your databases as well. So you can get notified of when your utilization goes up by a certain amount, or when you're close to hitting your limit of storage utilization, for example, and then you're easily able to scale up or down as necessary. Okay, so Flashback, is a database feature that you should all be hopefully familiar with. But Flashback comes with autonomous database, like many other database features comes with autonomous database. Right, so creating a Flashback archive enabled table is be able to basically recover a table or a set of tables in the past, right? And this is available with Flashback time travel. So time travel actually allows you to essentially go back in time, right? You can query or compare with older data, or look for erroneous data with Flashback Flashback queries. You can also bring back a table from the dead with Flashback drop, right? Just as an FYI, I have linked when Marco sends this deck out, I have URLs to many of these things that we'll be talking about on these slides that take you directly to some of these features, or blog posts that actually explain how these features would work. So I urge you to follow these URLs, and it'll take you to the right place. Right? So just to finish up on this, yeah, you can bring back a table from the dead with Flashback drop, like I mentioned. And then we also have things like Flashback version queries and transaction queries, right, where you can compare data between two time intervals, or even display this versioning in an application if you would like to have version control or something like that. These are database features that are available in this database, like I said, Oracle features. So this should look pretty familiar to you. Okay, so automatic backups is, like I said, is a huge aspect of basically minimizing risk without you having to actually set up or configure anything. Right? Every autonomous database with no user action basically takes automated backups up to your selected backup retention period. Right? The default is 60 days and has been, but you can, with eCPUs, which is the new billing model, you can actually change your backup retention period. If you don't think you need 60 days worth of backups, you can change it down to 30 days or 10 days. But the idea here is that you don't have to take any backups yourself. Right? This just happens in the background. And then you can also basically go back in time at any timestamp. This is not, an individual backup that's allowing you to go back to an individual point in time. You can go back in time to any of the timestamps available to you within your automatic backup retention period. Right? In addition to automatic backups, which is up to 60 days, we also have long-term backups that I think came out last year, a little over a year ago, where you're actually able to create much longer backups, up to 10 years, where you can create, and you can actually schedule your long-term backups as well. Create them monthly, you can create them yearly. And this, as we heard from many customers, this sort of helps you with compliance requirements, legal contractual obligations, but also allows you to, go back in time if you want to have a historical timestamp of your database and go back in time and clone from that. Okay, so we talked about backups and your ability to make sure that your database is bring backable, I guess. But when your database is actually running, we want to make sure that with application continuity, that your application continues to get basically run as though there's never any downtime, never any connection drops. Right? We want to mask any kind of downtime that's available to that's coming out of your database. So broadly, there are two sort of situations that you have to think about, right? Planned maintenance situations, where you have to sort of during your maintenance windows or any planned maintenance on your end. But in addition to that, your unplanned outages, right? Which, of course, from the application point of view, will be application continuity, and then later on we'll also talk about disaster recovery for unplanned outages, right? So since your apps will now no longer be halted with online patching and upgrades and those things that we talked about in previous slides, when connecting to Autonomous Database, the Oracle database basically auto configures FAN, which is fast application notifications, via the connection manager, via the CMAN. And for application deployments with ADB, FAN events actually help with unplanned outages, and these are directed to the connection manager, like I said, but with no client application configuration necessary. Right? So this is basically used to drastically reduce wait times without really having to do much in terms of configuration. That's for FAN. But now with application continuity, this can be enabled and needs to be enabled on the database. Of course, this should be familiar if you've used this on-prem. And so app continuity can be enabled and is used to drain connections and load balance during planned maintenance, or reestablish a dropped connection to the ADB, as well as replay sort of in-flight uncommitted work in the database. Right. So with the ability to replay in-flight work, an app can sort of continue executing without even knowing about an outage. That's crucial to the sort of continuous availability, which is what we talked about earlier, for an app that's connecting to the database. Right. So app continuity is built over MA best practices, which is basically Oracle's sort of blueprint for high availability. We actually have some configuration necessary on the database side, but you actually have no configuration that's required for application continuity on the application side. This is fairly simple from the app side. Like there's no code changed at all. And if it's already, if you're, like I mentioned earlier, if you're already using app continuity, whether it's on another database, an Oracle database, or on premise, they should look pretty familiar, right? It's identical across all offerings on the cloud, as well as on-prem, and so this should be easy for you to learn how to use. And like I said, we will have folks from the app continuity team come in and have a presentation in a couple of weeks to actually walk you through the detailed steps of these things. Right, so app continuity works basically over connection pools, and it sort of tracks session states to help you, replay in-flight work, right, and simply hides dropped connections and in-flight work from a user application. In addition to app continuity, of course, we have transparent app continuity, so the two categories of app continuity. Now, TAC also rebuilds session states and is able to replay in-flight work. But the idea here is that from 18C onwards, TAC is actually able to work with and without connections, right? So this can work with, without essentially what's called traditional begin and end request boundaries, which basically means it's simple markers that bound units of work in the database. So this is basically, TAC is a really great resource to sort of mask hardware, software, network, storage, and even session errors from your application, and is something that is easily set upable, like I said. So we will, like I said, have, the TAC and so the AC folks come in and give you more details about how to enable these things in an ADB. Okay, so the primary reason that you're here, let's talk about disaster recovery statements. So, broadly speaking, we have two sort of offerings for disaster recovery. Right? We talked about the ability to mask things from your, outages from your application, as well as, when there's corruption or erroneous data, to use backups, right? And those are the two categories of things that before you get to a disaster type scenario. But in a disaster type scenario, these are the two options that we have. Autonomous data guard, which, hopefully most of you are familiar with. This is what we originally had for I think a few years now. And this is for your most critical, most low RTO requirements databases. And then we have backup-based disaster recovery, which was introduced more recently, I think sometime last year. And this is your lower cost option, which, we'll go into details about, how that works. But this is basically for your less critical databases, which have a higher recovery time objective. I do want to mention what RTO and RPO are over here. So RTO is basically a recovery time objective, which is essentially the amount of downtime that your business is willing to recover from, and that's usually calculated in minutes in RTO time. And RPO, which is recovery. Sorry, I'm stuck again. So recovery process objective. So that's basically data loss, right? And data loss is the amount that the amount of data loss that your company can withstand is the RPO time. So RTO and RPO, we will talk about what ADG and backup-based DR, the RTO and RPO you get from those. Right. So within Autonomous Data Guard, you have local autonomous data guard and cross-region autonomous data. Right. These again should look reasonably familiar. Local autonomous data guard is of course for in-region. This is within region outages. Cross-region, as the name suggests, is cross-region. Local, of course, is the recommended situation where you don't actually have a full outage in the entire region, and when you don't actually want to, sort of have your full stack failover from one region to another. Right? So this tends to be quicker. It tends to be, more seamless in terms of, how your application is seeing the database, and we'll go into a little bit more detail about that. Cross-region, of course, is a little more involved in you having to go from one region to another, but you're basically protected in, for both situations. So you can actually have one local and one cross-region disaster recovery peer. And this is true for either ADG or backup-based, right? So you can have one local and one cross-region, either ADG or backup-based peer today, right? And we'll talk about your other options for multiple cross-region DRs, which is coming in the future in a few slides. So let's go a little bit more into local ADG, right? So this, like I said, protects against your within region outages. This is basically active passive replicated. So if your primary is essentially refreshing, so your standby is sort of refreshing data from your primary, as in the image over here. And you're able to, manually switch over and failover. But in the local case, we actually have automatic failover also available. Right. So as long as we, connections that are coming in, we can simply detect whether there is a constant stream of dropped or missed connections. And if that's true, we will basically, fail you over to your standby database. And the failover in the local ADG case is seamless, right? We don't even expose currently the database to you in the local case. We have a database that's just standing by. And when you do a switch or a failover or a switchover in the local case, this is a seamless switchover, right? Everything from your app's point of view remains the same, right? The connection, the wallets remain the same, the URLs to use any database tools like Oracle machine learning, those kind of things all remain the same. So this is, as I mentioned before, when there's not a regional outage, you would want to use this local ADG option for your most critical databases because it's essentially seamless, right? And this also, like I said, local ADG does protect you from AD outages in a multi-AD region, right? So we guarantee that you'll be on a different AD in multi-AD regions, and we also guarantee that within a single AD region that you're going to be on different Exadata machines, which is making sure that if you have a very localized machine-based outage, you can simply switch over from one database to your standby, and then you'll be running as long as it's just a minor local outage, right? So we talked about the maximum data loss that organization is willing to suffer, as well as the downtime, RTO and RPO, right? Those are the two terms that we talked about earlier. So in this case, the maximum RPO that we guarantee with, which is the data loss aspect of it, with local ADG is only 10 seconds. So that's the max, and usually it's significantly lower than that. Usually, as long as we can recover, most of your data, that we try and aim for no data loss, right? And RTO, which is when you switch over from one primary to the other, from one for your primary to your standby, the maximum amount of time that we guarantee will be 2 minutes. But again, that's the high watermark. In most cases, you will be switching over much quicker than 2 minutes as well. So cross region. So like I said, in this more rare case where you have more regional based outage, it's a simple one click, and I'll just show you a quick screenshot of how you actually enable these things. It's a quick, like it is for ADG, it's a one click for adding a database in a different region. And this, when you do actually fail over from one region to another, as you would expect, it's a little more, right? Your URLs that are in Apex or ML, your tools or your wallets will actually change, right, when you're moving from primary to standby. So we do recommend that you're testing these things by switching over and then using wallets and your tools on the other side. Make sure that your application is also available to use wallets on the other side. In many cases, you would also want to sort of fail over your entire stack in a true regional outage. So you want to stay, your mid-tier and your front end and all that. You probably want to fail over your entire stack and therefore test in that manner. Right? And I have a few examples of that as well. These two work in a similar manner in that this is active passive replication with remote and primary. But the RPO and RTO is slightly higher over here because it is, of course, going over from one region to another. And we also recommend that, like I said earlier, that in a localized outage case, you fail over to a local standby, and then in a more a region-based outage or an outage where you're not able to basically access anything in that particular region, then only then you'd want to sort of consider a cross-region ADG failover if that's necessary. So the RPO here, which is data loss, like I said, the max data loss that can be withstanded is 1 minute, which is still super low. And RTO is 15 minutes. So we'd fail over from one to the other. That's the absolute max you should be taking. Again, the average case is a few minutes to fail over from one into another. This is just a quick example of how you would be basically adding a cross-region ADG. It's as simple as creating, selecting add peer database, selecting your region, and hitting add peer database. And you wait a few minutes, and you will basically have a database lying in the other region waiting for you to be able to switch over and fail over. Right? Yeah, this is the slide I was looking for. So, with ADG, we are guaranteeing that you have a high availability SLA. So the default for any autonomous database, which is below, is we guarantee 99.95% availability, right? With ADG, we actually guarantee a higher availability with 4 nines and a 5, 99.995%. In addition to making sure we have this guarantee, we also do have availability metrics that we put out. I have linked this here as one of the many links that is in the slide deck, where we actually show you per region the availability for that region, as well as the manageability and all, some of the other SLAs that we have available shown on the Oracle Cloud version of this as well. Okay, so we talked about ADG, which is the the more critical database-based disaster recovery. But for your less critical databases, we have backup-based disaster recovery. Right? So this is same. It should look very similar in terms of functionality, in terms of user interface, and even in terms of adding the peer database as ADG is. But the idea here is that instead of having a database standing by so that you can switch over to, which is obviously the quickest option, we actually allow you to basically have switch over and fail over using backups as your disaster recovery solution. And this again from a user's point of view, from your guys' point of view, will basically be seamless. You just do a switch over or failover, but we will only be instantiating the standby at the time of switch over failover via the backups that are being taken. Right, so the backups are basically being taken constantly and are refreshing from one side to the other, the backup and the redo logs, of course. But we'll actually be only creating or applying those redo or backups to a particular database, like I said, at the time of switch over failover. So this is where the cost savings come in, right? You don't actually have a CPU-based database running on the other side. It's just backups that we're taking on the other side. So like for ADG, we also have the same situation. For local backup, for local outages, you'd use local backup copies. Like I said, the backups are automated, so there's nothing for you to really do or set up. And therefore, by default, everyone has local backup-based disaster recovery. Right? You can, if you think you have an outage on your existing the current Exadata machine or the current availability domain that you're on, you can simply do a switch over to your local backup copy, right? And that is automatically available, nothing for you to set up. And for, like I said, more rare outages, you can also create a cross-region backup copy where we would be sending that same set of backup and redo, not just storing it locally, but sending it across to the region that you've selected, right? And of course, with the way this actually works, like I mentioned, the RPO and the RTO, the RPO will be similar to ADG, but the RTO, which is the recovery time objective, the amount of time it takes to go to the other side, will actually be longer than 15 minutes or 2 minutes, as it is with ADG. It'll be based on the size of your database. So we have, over here, it takes about an hour plus an hour for 5 terabytes of data, approximately, right? This, it's obviously that's the max, like I said, with RTO. It usually happens in a much quicker time period. And sorry, just to mention one last thing here, that local backup copies are essentially included, right? So it's included with your existing backup situation, right? So if you're using eCPUs today, eCPUs backups are charged separately since storage costs are cheaper. And on OCPUs, backups are included with the the higher storage price on OCPUs. Again, eCPUs and OCPUs, if you're not familiar with that, have a look at it, but it's basically just two different billing models that we have with Autonomous Database. But in both cases, your backups are basically, your local backups are basically included with local backup-based disaster recovery, right? There's nothing additional that you're creating or paying for in the backup-based disaster recovery case. An important part of being able to, make sure you have your disaster recovery properly set up and tested is Snapshot Standbys, right? So Snapshot Standbys should look familiar if you've set up disaster recovery on-prem at any point in time, or other databases in Oracle Cloud. But Snapshot Standbys basically allows you to open your standby in read-write, right? Currently, by default, your standby is just standing by. It's not available for connections or able for you to open and read-write. But basically, if you want to be able to test your standby database without affecting your primary in any way, right? Or you want to actually do any work on your standby database in terms of setting up configurations with application stacks or anything like that on the other side, there's another case where you might want to use your WebLogic server connecting to your standby database in the other region, right? You can actually use Snapshot Standbys and open your standby temporarily in read-write, right? And you can read-write, and then in a few in the period of time that you actually need, or automatically it will convert back to a standby database, an ADG standby database, or backup-based standby. But the idea here is that, like I said, you're not affecting the primary when you convert from one to the other, and you're able to, input data and set up configurations on the other side. In addition to snapshot standbys, we also have a more recent feature, which is cross-region backup replication, right? So previously, we were taking backups on the primary database, and of course, you're protected for the time period that you're actually running on the primary database, but we weren't replicating your backups to the standby. Recently, we enabled this feature where you're able to actually replicate up to 7 days worth of automatic backups from primary to standby. So what that means is after you do a switchover from one side to the other or a failover, you're actually able to just go back in time up to 7 days immediately, because we've already replicated that amount of backups from one side to another, right? We did talk about failovers and switchovers and that kind of thing. I want to go a little bit more into detail about what these look like, right? So automatic failover we talked about, where basically your primary is down and can't be connected to, you're sending connections in and can't be connected to for some reason, there's some outage. By default, we will automatically fail this over in the local case if you have local ADG enabled. But then this is seamless, like I said, it'll, in a few minutes, it sort of just switches in the background, and you're suddenly switched over to your local ADG, and you're up and running without anything for you to do. Right? By default, we have your local autonomous data guard automatic failover set up with 0 data loss. Right? We want to make sure that any automated action is not obviously taking any data loss without user intervention here. Right? So as example here, the primary is down. Just because you've switched over automatically without the user doing anything, you're able to basically, it goes into an updating state. And then, like I said, it just, becomes available. So this looks pretty magical. Like I said, so by default, the local automatic failover has no data loss. We actually introduced last year a feature where we're able to provide an option for you to select the amount of data loss that your organization is willing to withstand, and basically have an acceptable amount of data loss when you're essentially prioritizing uptime, right? You're saying, up to X amount of data loss. In this example, 60 seconds is something you might say. Up to that amount of data loss, I want to prioritize automatic failover and make sure it's going from primary to standby. And like I said, you're prioritizing uptime with that situation. In addition to automatic failover, which is, comes inbuilt to local autonomous data guard, you're of course able to do a manual failover or a manual switchover, right? So I don't think I mentioned switchover in detail, but just as an FYI, a switchover is basically a no data loss guaranteed switchover from the primary to the standby database. And that's, we often encourage people to use that in testing to make sure that you're testing that your switchover is happening from one side to the other, and then your applications are actually able to test on the standby database that's now the new primary when you've switched over, right? In the manual failover case, you're basically saying that you're saying I'm willing to withstand whatever data loss is available. It might happen here. Again, this is the maximum amount of data loss that may happen, but it's usually less than that. And the step number 1 that we do at any kind of failover or switchover, step number 1 is we try and minimize any potential data loss, right? So when you're clicking manual failover, this is available both in autonomous data guard and of course in backup-based disaster recovery, both on the UI and via an API call. So you have these many different options. When you click a manual failover, it looks similar to your automatic failover. Right? You're basically saying I'm failing over from primary to standby. It'll take a few minutes. In the local ADG case, it may take slightly longer on the cross-region case. And in the cross-region case, you're actually calling failovers from the standby side, right? Not on the primary side, just as an FYI. So this is the option for you to basically manually failover in to your standby database in the rare case that there's an outage. I did want to mention full stack disaster recovery because this is, we talked about the disaster recovery options within Autonomous Database. But we do actually have a separate service on OCI, on Oracle Cloud, called the Full Stack Disaster Recovery Service that provides this more comprehensive recovery capability, right? So we talked about you failing over or switching over your database from one side to the other. But often in the cross-region case, you may actually want to consider failing over your complete stack from the primary region to the standby region. And in that scenario, you may actually go in and set up full stack disaster recovery. If we have, if we have interest in this, Marcos, we can consider, getting the full stack DR folks doing a presentation here as well for our customers. And basically, what this means you've sort of pre-configured your application, your VMs, etc., with full stack DR. And then instead of doing a failover or a switchover simply at the database level, you may go into full stack disaster recovery and do a failover at that level. So like I said, where you're failing over your entire stack from one region to another. So I just wanted to mention that, VCN Peering, this is a sort of an edge case. I just wanted to point it out here that if you are setting up, if you have private endpoints, which is, a private database versus your publicly accessible database without, having any ACLs or anything like that, any access control lists or anything like that. So when you have a private database that's lying in your virtual cloud network on Oracle Cloud, and you're trying to connect from another region's private endpoint as well, right? You may have to set up VCN peering when you're trying to connect from one, like I said, one private network to the other private network on the other side. I don't want to go into too much detail here because that can get confusing, but I have linked the blog post that I have. So if you are already using the 30% of you that are already using or familiar with Autonomous Data Guard or backup-based DR, and you think you may want to connect from one private subnet in one region to a private subnet in the other region, you may need to set up VCN peering, and we can talk more about that if necessary. I did mention that you can basically have, one local disaster recovery peer and one cross-region disaster recovery peer today. Just as, an FYI for a roadmap item that is coming up is the ability to be able to create multiple cross-region either peers in one region. So the idea here is you'll basically be able to have either an ADG or a backup-based DR in the set of regions that is connected to your current region. And you'll basically be able to switch over or fail over to any of those regions. And we have gotten this requirement either as a compliance requirement or just for general multi-region protection. We have got this request from multiple customers. So just as an FYI, this is coming soon. That's pretty much it. So just want to highlight some of the key takeaways we talked about. We talked about, the ability for Autonomous Database to basically always be patched and upgraded online with no database downtime and with the right events that's available to you. You're able to recover your Autonomous Database using Flashback, using full database restore, using backups. We talked about application continuity, which we'll have a more detailed talk in the future, like I said, but that is essentially used to make connections seamless, right? So it's basically masking any outages from your application, right? It's masking the underlying infrastructure outages from your application, and it just looks like it can continue and replay any drop sessions. We talked about the new lower cost backup based disaster recovery that we introduced last year. That's for less critical databases. And then, of course, for your most critical databases, the highest availability option that we have is Autonomous Data Guard, which guarantees 99.995% availability. And of course, you have both, local and cross-region Autonomous Data Guard, as well as backup-based disaster recovery for those options. So thanks for your time. Hopefully, much of this was clear. Hopefully you got a better picture of the sort of the overall disaster recovery story and high availability story in ADB. These links, I think, would be useful to basically everybody here. So Marcos, we can send this deck out, I suppose. sometime later today. But basically, of course, if you don't have a Oracle Cloud account yet, which I hope everyone here does, you can go ahead and create an always free database. Just to note that disaster recovery is not available in always free. So, if you are going to be testing disaster recovery features, you would want to either do the free trial or be using a paid Oracle Cloud account. But more importantly, we're constantly updating our blogs with the latest features, things we talked about here, cross-region backup replication, backup-based DR. We always have blog posts for each of these things. So follow our data warehousing insider blog. We also have live labs. So live labs, if you're not familiar with this already, are basically workshops that step you through step by step some of these features, right? Whether it's autonomous data guard or auto scaling or many of the other features associated with the Oracle database, as well as other products, right? We have a whole set of workshops that are just simplistic step-by-step examples of how to use these features and products. And then, of course, we have the ADB documentation. And of course, like I said, we are posting on the blog posts, the insider blog, but we're also posting on Twitter, and that's my Twitter handle, as well as we have a channel for the whole ADB product management team, so you can follow all of us in one click. I think that's it. I will hand back to you, Marcos. Thanks.
Thank you. Yes. So guys, if you have questions, feel free to type it in. There are a few questions coming in. Nilay, you can take a look. Yasin and Valentin were answering 40 questions already. Thank you, guys. Lots of questions and good questions. Nilay, you want to take one there?
Oh, there's one question. Yes, I see that. Yeah. Can we have reduced sizing for the standby DR instance? We've gotten this question before, and that's actually why we introduce local backup-based disaster recovery, right? So no, you can't have a separate standby sizing, right, on the primary and standby. Right? The primary database, let's say, is X amount. Let's say it's 4 eCPUs. You enable standby databases. Your standby ADG standby will also be charged as 4 eCPUs. But that's only in the ADG highest availability case. If the requirement is lower, and if the amount of if you want a low cost option, you'd simply enable backup-based DR, and there's no CPU charges at all for enabling backup-based DR on the standby database.
Right, and I think also another comment would be that you could use also auto scaling, right? So if you use auto scaling, the when you're scaling up or down, yes, those CPUs are not charged, right, on the ADG side, correct?
Correct. That's true. So if you have auto scaling enabled on the primary database, then you're basically only paying for the base amount of CPU on the standby database, nothing that's auto scaling up and down on the stand. That's right.
Okay.
The standby database I mentioned earlier is not an open database, right? You're not performing read-only queries or anything like that on the standby. And if you want to, you can open it separately as a snapshot standby and use it temporarily as a read-only or a read-write database. Is that reliable and same like GG Replicator? Well, yes, it is reliable. I'm not sure what your question was about Golden Gate. But it is replicated. It's basically refreshing data from primary to standby, which is similar to Golden.
Okay. Still some questions coming.
Lower the number of business hours, but that reflect on the DG. Yes. So if, Roxana, if you scale up or down your primary database during hours where you're not expecting to use that database much, that same amount that you're on the primary database would be reflected on the standby. That is correct. And that's sort of where auto scale comes in, right? So if you're actually auto scaling effectively, and your baseline CPU is only what you would require during lower when there's lower activity on the database, that's the amount that you'd be billed for on the standby, and you would not be billed for any auto scale value or any scale up or down value. That's the correct one that you see on the standby. Yes.
Okay, guys. Perfect.
We have a solution for fully active setup with transactionally consistent and synchronously replicated databases. So if you absolutely need an active setup, we do have efforts in, basically lowering the RPO time and, getting closer to data loss, getting closer to no data loss, sorry. But if you genuinely need a fully active setup, that's not what autonomous data guard is, right? So that you may think about setting up Golden Gate, if that's one other option. It doesn't really cover your disaster recovery option, which you may still want to have, but it does cover you actually being able to have a fully active setup as well.
All right. Excellent. So we'll still leave the Q&A open. I'll just leave you guys with a couple messages. Important links again. All of these links are going to be as well available to you guys in ADB Get Started. So if you go to the Get Started, I'm just posting them again here. So you guys have it handy. And if in terms of recording, so final thoughts for the recording is going to be back in the bit.ly/ADB Learning Lounge. So if you look at the link on top, that's where you're going to find, recordings, upcoming sessions, right? And the links are going to be there as well. Okay. So I'm going to be working, I'm working with the teams as well to get a session like Nilay was saying, one on, particularly on application continuity. We're going to announce the session on when we get the correct dates. And well, basically that's it. Again, thank you very much, Nilay, for your session. It was great. And guys, I'm going to leave the Q&A open still for a few minutes. If you have any other question that you guys remember, please make sure to type it in there. Okay, guys. Again, thank you for joining, and talk to you guys in the upcoming weeks.
Thank you, Marcos. Thanks all.